Hello, I welcome you all to this another interesting screencast. Thank you for your support. Continue liking, sharing, and watching my videos. Yes, so that I continue providing this particular service. Let's get back to the problem. We have two problems here from the Engineering Mechanics Statics textbook, 13th edition by R.S. Hibbeler. And the first problem reads, determine the magnitude and the direction of the resultant force, FR, F1 plus F2 plus F3 of the three forces by first finding the resultant F prime equal to F1 plus F2, and then forming another equation where we have FR equal to F prime plus F3. In the second case, we are to change the order. F prime should be first equal to F2 plus F3, and then later on FR should be equal to F prime plus F1. Of course, there are several methods to solve this, one of which we can solve this just using the components, where we draw the table F1, F2, F3, and then we have the resultant. We could do this, which is quite easier. Okay, so we have the X component there in newtons. We have the Y component in newton. Then we start filling up this. Okay, we could do this, all right, and then later on find the resultant frx, fry, and the resultant, which is just equal to square root frx plus fry squared, and theta is just equal to tan inverse of fry and frx, and related there how we want it to be positioned and so on. We could use this, but here we want to just use the parallelogram to see how we can sum up vectors more than 2. Okay, so we use the parallelogram. So when you have vectors that are more than 2, scaling, at least some scaling when you are drawing the parallelogram becomes a little bit vital, because sometimes if you don't done the right scale, the angle begins to turn negative and so on and so forth. And by this I mean, when you have more than 2 vectors that you're adding, you need to at least just have that eye to say, if this is 30, that's the magnitude which is being shown by the length of the vector. This is 20. So you can just have that intuition to say, wow, okay, this must be longer and so on and so forth. Something like that when you're drawing quickly. Okay. Short, maybe somewhere there. All right. All right, something like so. All right, this is not bad. So the two vectors, these ones like so, and then these ones like so, and then we have the resultant like so. All right. So there we go. Let's label them quickly. So this is FR. This is F prime. Sorry. This is F2. This is F3. I mean F1. All right. F1, this is F2. Great. So here let's add some more details. This is 20 degrees, of course. And if this is 20, we know that this is just going to be equal to from there to there. Okay, it's 90 minus 20, right, which is equal to 70. All right, so this is 70 degrees. Okay, this is 70. All right, And then we have this angle here. We have this angle here that I'm going to call, let me call this as alpha. Okay, let me call this as alpha. And then let me also find this angle here. This angle here. This angle here is being governed by this triangle here. So this just, let's call it beta. So beta equal to tan inverse of opposite over adjacent. So this is just going to be equal to 3 divided by 4 there. Tan inverse of that, this gives us a 36.87 degrees. 36.87 degrees. Alright. So we have all this information. Let's find some more. We have this angle there, okay. What else do we need? We need to find, what else do we have? This one there is 36. Okay, we have this and this. So we can find this angle here. Let's find this angle here. Let me use this here. Let me draw that here. Sorry. Yeah, like so. Alright. This angle here. This one, this is F2. This is F2 there. So we know that this angle here is going to be equal to 20. Okay. And then this angle here. Okay, since this is the right angle, since this one here like this is the right angle, right? Can you see it? Therefore that angle there is just 180 minus 90 minus 36.87, which is just equal to 180 minus 90 minus 36.87 is a 53.13. Okay, so let's feed it in. Let's feed it in. Okay, so this angle here, of course this one we had said is a 20, and we are finding this one here. We said this one is equal to 53.13 degrees. So we are good to go. Let's use this top triangle for working out. They are similar. So once we have that, let's call this one as case 1, which is a 2-19. So once we have that, let's apply the the cosine rule to find f prime. So f prime is just going to be equal to f prime using the cosine rule is just equal to we are starting with f1. This is the order. F1 plus f2. So f prime is just equal to f1 squared plus f2 squared minus 2 by f1 by f2 cos 20 plus 53.13. Okay, then everything under a square root. So we have f1 equal to, f1 is equal to, what is f1 equal to? Is equal to 30 newtons. F2 is just equal to 20 newtons. Feeding those into our equation, gives us, feeding those into our equation gives us, let's do that. So 20 squared plus 30 squared minus 2 by 20 by 13 by cos 20 plus 53.13, and the square root of that. This gives us a 30.85 newtons. Right. Here we go. So let's find this alpha. Let's find this alpha. It will be vital in our second case when we draw this. Right. Let's find this alpha. Alpha. Okay. Let's find it here down. So if we are to write it down here, then we'll say sine, going to use the sine rule, sine beta plus alpha divided by f2 is equal to sine 20 plus 53.13 divided by f prime. We know what f prime is, we know what f2 is, and we know what beta is. So feeding all this, let me write them down. Beta is equal to 36.87 degrees. F2 is equal to 20 newtons, and F prime is equal to 30.85 newtons. Okay, therefore alpha plus, making alpha plus beta subject to formula, alpha plus 36.87 is just going to be equal to, do calculations there, f2, so we are multiplying f2, that's 20 sine 20 plus 53.13, okay, divided by f prime, which is 30.85. Okay, then sine inverse of that, it gives us a 38.35, and therefore alpha is just going to be equal to a 1.48. So found what alpha is. It's important, we need it. So let's look at f prime. F prime is 30, then f3 is 50. So f3 is a little bit going to be longer when we draw our parallelogram. That is very vital to remember. So we are saying f3, f3 is 50, it's longer than f prime. So when we draw this, now we are drawing the second parallelogram. We are here, here, okay. So let's draw. Okay, there we go. Let it maybe be something like this. Okay, yeah, I think so, something like this. And then the other one will be something like this. Okay, something like this. I think so. This is good enough. I think so. So we draw the arrows there. Yeah, we draw like so. And then this one we draw like so. Okay. Alright. And then we have the resultant. So it's important to have that intuition, especially when you are dealing with more than one vector. If they are just two, is fine. But more than them, more than one, It's important to have that intuition. Right, like so. So let's label them. So this one is f prime. Okay, this one is f3. Of course, this is f3, like so. Okay. Then this angle here, is equal to alpha. Okay. Then this one here, this is equal to FR. Alright, great. And then of course the direction, this direction we are going to assume, this direction this is direction with respect to this direction will say measured. Of course, every time we mention of direction is always measured anti-clockwise, okay, anti-clockwise from the positive x-axis. So here it's not mentioned, but let's assume our direction. So this one will say measured clockwise, okay, measured clockwise from the positive x-axis, okay, positive x-axis, and it will also apply for the second case. All right, okay, I wanted to make mention of that. So if that is our assumption, then the direction we'll be looking at will be this one here, okay, and we'll call this direction as theta. Okay, great. So with all that information, then we can find FR quickly. We are just going to use the we'll use the cosine law. So FR is just going to be equal to f prime squared plus f3 squared minus 2 by f prime by f3 cos alpha. Okay. The equation looks small. All right, this is fine. So we have f prime is equal to 30.85 newtons. We have f3 is equal to what is f3 is equal to 15, and then we have alpha is equal to the 1.48 degrees. Let me just create a boundary there, like so. Okay, there we go. All right, so let's calculate. We need to find FR, so just grab your calculators and plug in the values. So FR is just going to be equal to 30.85 squared plus 50 squared minus 2 times 30.85 times 15 cos 1.48 square root of that. We have a 19 point. We have a 19.18. 19.18 rounded off. Okay, and then let's find theta. We use sine law. So say sine theta divided by f prime is just going to be equal to sine alpha divided by FR. Okay, therefore theta is just going to be equal to, we know what these are. Let me just move this a little bit up. I move them there like so. We know what alpha is. Alpha is just 1.8. F prime, we know what F prime is, and FR, we know what it is. So we have everything. Once we make theta subject to the formula there, we just have F prime, which is a 30.85 sine 1.48 divided by FR, which is a 19.18, and then sine inverse of that, we get a 2.38 degrees. All right. So this again is measured clockwise from the positive x axis. All right. So we are done with the first case. Let's move to the second case. Let me just create a boundary here. I create a boundary like so. Great. So let's draw again here. All right. So in the second case, of course, when you look at the two vectors 20 and 50, we expect the other one to be a little bit longer. Let me move this maybe a little bit there like so. This is case number 2. So let's say this vector 50 is maybe up to, it's a little bit longer, right? It's more than twice, right? So let's say maybe it is somewhere there. Okay, we can say up to there. Okay, all right. Therefore, we'll write this like this. Something like so, and you'll have something like so. Okay, so there we go. Something like this, something like that. Something like that. Okay, yeah, something like that. And then let's add some details. Of course, we know that this is 20 degrees, and if this is 20, if this was made a right angle like this, then this would be equal to, that's just 180 minus 90 minus 20, which is just going to be equal to 70, right? Because 180 minus 90 is 90 minus 27. So this one here is 70 degrees. Agree? Then let me rub this now. Okay, I just rub this right angle there like so, because it's one like so. Great. So if that is 70, of course we expect this also to be 70 degrees. What else do we have? Of course, this one here is f prime. This one here is f3, and this one here is f2. Of course, this is f2, and then this is f3. Okay, all right, f3 is visible. Okay, so there we go. So we have two triangles. We have this and this. We're going to use that one. They are the same. Okay, So let's start working out. We'll need to find f prime using the cosine law. So we'll say f prime is just going to be equal to f2. Mind you, this is what we are following here. This is the first case. We are adding f2 plus f3. That's what we are told. Asked rather, f2 squared plus f3 squared minus 2 by f2 by f3 cos 70. Okay, there we go. And then we have f2 equal to f2 is equal to 20 newtons, f3 is equal to 50 newtons. Our f prime therefore is just going to be equal to, let's calculate, this is 20 squared plus 50 squared minus 2 by 20 by 50 cos 70 square root. This gives us a 47.07 newtons. Alright, let's also find this angle here. Let me call this angle here as my alpha. Alright, let me find my alpha. I'll need it. So I'll use sine law. So sine alpha divided by f2 is just going to be equal to sine 70 divided by f prime. And we know what f prime is and and f2. Therefore, alpha is just going to be equal to, make alpha subject of the formula. Alpha will just be equal to, if you calculate alpha, f2, that's 20 sine 70 divided by f prime 47.07. Okay, sine inverse of that, we get a 23.53 degrees. So we found alpha, we found f prime. So what we need to do now is to draw another parallelogram. We'll draw another parallelogram with f1 and f2. This one here, f prime and f1 rather. Alright, the sizes, they don't look bad, but maybe a little bit exaggerated. That is not bad. So we'll do this. Let's draw. Let me use a straight rule. Something like this. Something like this. Okay, something like so. And then we use that, something like so. Okay, this is not bad. So the green is parallel to f prime, and the blue is parallel to f1, and then we have the resultant from this end to there. Okay, and this angle here is disturbed, so let me write it somewhere. I say I just move an arrow like so. I call it I move an arrow like so, then I call it like I'd called it as alpha, and I draw my resultant from this point to there, like so. Great. And this resultant, this one here is our resultant. This one is equal to, oh Lord, this one is equal to it is equal to, this one is equal to FR. Okay, then we have this angle again. We have this angle, this angle, this angle. Okay, there is this angle that we need to define. Okay, we define it, we'll come to that later on. So now we have this information here. This is not well defined. Let me say I use red. This one is equal to FR. Alright, like so. Great. Okay, so now let's add some details. Let's draw a coordinate there like so, at this point here like this. Okay, so we can find this angle here. We can find this angle here. Okay, this angle here, we can find this by using this right angle triangle, which will be similar to this one here. Okay, no, not that one, to be similar to that one there, like so. Okay, so this one is just going to be equal to, this is equal to alpha. Let's call this as not alpha, this is beta. Let's call this beta, which is also going to be equal to that one there as our beta. So let's say beta is just equal to tan inverse of 3 divided by 4, and we calculated beta, if you remember, it is just 36.87 degrees. So found that. Then we need to also find something. We need to find this angle. This angle, where is the resultant? We found alpha. We've seen this alpha there. Alpha with this particular f prime, and therefore this angle alpha is also equal to this one here. Okay, this is alpha here. Okay, you agree? This is alpha here. So let's say this one inside here is gamma. Okay, that's gamma. Okay, so if that is the case, then we'll say, we're going to say, let me just create another boundary there so that stuff. Okay, there we go. So gamma therefore is just going to be equal to beta minus alpha, and gamma is therefore equal to gamma is equal to beta minus alpha, and gamma is just equal to, what is beta equal to? Beta, we said, is 36.87 minus alpha. What is alpha equal to? Alpha is 23.53. Therefore gamma is just equal to 36.87 minus 23.53. So this is equal to 13.34. Okay, 13.34. So what it means is, for us, of course, we are just going to use the top triangle, this one here, to do the calculation. We could use the bottom one as well. We'll use, if you want, we can even use the bottom one. There is no big deal. We could use the bottom one. Okay, because this angle is the same there. Okay, this one is our gamma. So let's use the bottom one. No big deal. Doesn't matter which we use. All right. So using cosine law, we can say FR FR is equal to F prime plus F1. So this is F1. Okay, so F prime squared plus F1 squared minus F prime, then F1, then cos gamma. Okay, and everything under the square root. And then we know that F prime, of course, is already given. We already calculated it. It is 47.07. F1, we already know is given. It's equal to 13. And gamma is also calculated is 13.34 degrees. So feeding all those, we get the resultant equal to 47.07 squared plus 30 squared minus 2 by 47.07 times 30. Okay, then times cos 13.34, everything that, and then square root of that gives us 19.17 newtons. Of course, in the other case we found 1.8 because of rounding off. All right, so we have FR. So now we need to find the direction. So this is the direction. Again, we said the direction we're going to measure it clockwise with reference to the positive x-axis. So this one here is the direction we are looking for. Okay, this one there, we call it alpha. Okay, so for us to find alpha, is it well represented? So we are talking of this one, this is theta. So for that, to find that, we need to find this one here. We need to find this one here that we are going to call phi. Okay, so there is that phi in between there. So for us to find phi, we can use sine law quickly. I also say sine phi divided by sine phi. Let me write it down here. Sine phi divided by f prime is equal to sine gamma divided by FR. Okay, and we know already these values. F prime, we know what FR is. We're just from calculating it. We know gamma. We can feed them in there and then find what our phi is. Our phi therefore is going to be equal to, so we have 13 sine gamma, which is 13.34, divided by FR, which is 19.17. Then sine inverse of that, we get a 21.17 degrees. Okay, and therefore we can simply say, once we found this, let me check it again. 30 sine 13.34 divided by FR, which is 19.17, sine inverse of that, okay, 21.17. Great. So now therefore theta is just equal to alpha minus phi, right? We know what alpha is. Alpha is 23 point. Alpha is here, right? Here is alpha here. Okay, just feed it in there, then do the subtraction. So alpha, so we have the 23.53 minus 21.17. So this gives us a 2.17. a 2.36. Okay, that's 23.53 minus 21.17, 2.36. Great. Again, this is again lower than that because of issues of rounding offs. Okay. Let me just write down also here. I'd forgotten to indicate the case for this one. This one is case 2, which is a 2 dash 20. Right. Just underline it like so. Great. So let's outline all the solutions. We have f prime for the first case, f prime for the first case, which is a 30.85, and then uh, we have the resultant for the first case, which is 19.18. Then finally we have the direction for the resultant, and this is being measured from the positive clockwise from the positive x-axis. In the second case, we have f prime equal to 47.07. Then we have the resultant, which is 19.17. The difference between the first case and the second case is 0.01. The reason being that because of rounding off, and so is the angle. We have a difference of 0.02. Again, the difference is mainly due to the rounding offs. Right, I am done. I hope I'm done. Continue supporting me. Give me the likes, give me the thumbs ups, continue commenting so that the channel grows. Thank you for your support. Bye bye, and see you in my next screencast.